7.6 kilometer. Number 6 matches with C. Did we have number 6?
Yeah, we did. Yeah, it was kind of like it was constrained.
What do I have up there? Whoa, why are these partial fractions?
Yay!
Oh my goodness, I have no idea what's going on.
More time to do homework.
So I got the right numbers, but from the wrong section. Alright, Ricky, go hit backspace. Lame sauce, we'll go find them. And then can you hit Control Enter? Yeah, page break. Okay. I am so sorry. That's the same things we can catch it, okay? That's not going to help us right now. We need the book solutions, which is in the Explorer. Precalc. Okay, what? Is it close? I think frozen. Alright, let's see if Honors had something similar for them. They might have for the section. I feel like they were the same. It wasn't a long section. Still frozen. Okay, PDF is not working so well. Let's just see what we have. Section 7.6 was on system of constraints. That looks better. Can someone compare that to your assignment real fast? Does that look right? Okay. I was thinking it was a short assignment, so I probably kept them the same. Let's go steal those answers. There we go. Oh, that's a good one. Let's try again. No, that's not. There we go. Copies. All better. Paste. Okay, so hopefully the real number 6. Vertex. Is that better? Okay. What's going on? There we go. Number 6 is vertex. Number 14, let me give you a moment. They went ahead and sketched. And as they sketched, they were able to find the vertices 0, 8, 16, 0, 4, 0. They tested them all by plugging them into the objective, and lo and behold, 0, 8 was the lowest, hence the minimum value 4 at that point, maximum value 80 at the point 16, 0. And there's the shaded region for you guys to check real quick. Shaded region is just a triangle. The winner chicken dinner 0, 8 in one way, and then 16, 0 in a much different way. Alright, number 26. He was a little bit messier in his numbers. Remember I told you guys that? For these ones, you would be able to use your graphing calculators, but you need to understand how to find, for instance, the different vertices from the corners of the overlapped region, etc. And to be honest, I think if you're graphing lots of different constraints, it can get really confusing if you're trying to keep them all shaded with your calculator. Sometimes it's easier, remember, just to graph the lines and then figure out the shading on your own. Vertices were 0, 5, 22 thirds, 19, 6, 21 halves, and then 0, 0. When you test them, you got the minimum value at 0, 0, the maximum value at 22 thirds and 19, 6. Sketch, shade, find the vertices. Test, test, test. Find the lowest that they want minimum, find the maximum if they want, the highest that they want maximum. Cool. Number 40. He was a word problem. Is he the one where, was it refugees or something? They were trying to have different vehicles in order to transport people for something. I forget exactly the problem. But they did know that they needed at least 20 vehicles. There are a couple different constraints dealing with 690 and 520. Of course, it's quadrant 1 once again because they didn't want negative vehicles, and so that was understood. You might have written that down. You might not have. That's okay. But quadrant 1 was where we were looking because no negative Model A or Model B vehicles. With your three constraints, once you graph them all, your objective was the cost. I think you were trying to minimize the cost. Minimize the cost. Your shaded region was unbounded as the maximum, but we weren't trying to find the max. We were trying to find the min. So we take all of the corners of, hopefully use your graphing calculator. Could have used the 0 there. You could have found the intersection there and there. And then you could have used the 0 here. I apologize, that wouldn't be the 0, that'd be the y-intercept. Test those 4 points by plugging all 4 of them into the cost function. It ends up being the very lowest cost you could possibly get is when you had 10 vehicles of each. 10 vehicles of each. So the 4 vertices, testing each of them. Minimum cost $25,000 when 10 are used each. And I thought there was one more. Was 40 your last even?
Yeah.
Oh. I don't know what I was thinking. Alright, cool kids. Any quick questions on the odds or clarification on the evens? Oh no. So, real quick on tomorrow's test. You may have.
Wednesday.
Oh, I'm sorry. Tomorrow is the next day. I'll see you guys. Yeah, you're right, Wednesday. On Wednesday's test, there could be one as simple as this one, meaning the graph is pretty simple, pretty straightforward. You could totally do it by hand without a calculator. And you could use your math skills to figure out like the intercepts or the zeros by setting equal to 0, the equations, etc. and sketching. No word problem, no translating, everything's given for you, and then you just find the lowest or the highest, probably not both. But there might also be one word problem where you have to translate the equations to get them, and then to graph them, and then to compare the vertices to test. So that you know, from section 7.6, the only things I would possibly ask is one that's really straightforward. I give you all the different constraints and the objective, and I say, here, go with nice numbers. And, or I can ask you a word problem. So be ready, okay? Okay.
Yes.
Okay. 2 of you are saying okay. The rest of you hopefully are silently nodding in assent. Okay. Let's get back to your test review. This is what you guys had for tomorrow. I was really trying to be able to pull up your book. Oh, maybe it will work after all. I don't need book solutions. Let's get rid of him. I did tell you guys to bring your graphing calculators today because I was going to talk about real quick something that some of you already know how to use, and you might, I probably shouldn't say cheat with it. You might use it strategically to, yeah. So I wanted to make sure we were all on the same page. That way no one had an unfair advantage. For the part of the test that you are allowed to use the calculator on, there are the review exercises. Let's quickly just look at the different types of problems. Oh, come on. Work. Not responding. Okay, never mind. Let's say I was to ask you something like, x plus y equals 10, and 3x minus 2y equals 7. Okay, question. This is from chapter 7, like 7.1, 7.2, substitution, elimination. What's one way that you could solve this? Substitution, solve for, I'm guessing, one of these guys, right? Pick one. Sure, solve for y by subtracting x, plug it into the y spot, carefully not killing a seal, distributing that -2 to both pieces, simplifying by combining like terms. Done. You have x equals, and now what do? Go back, plug it in here, or plug it into your nice equation. Just wait until you plug it into, solve for y, and you're done, 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 done. What's another way of solving from 7.2? Elimination. You can multiply this entire top guy by what? Oh, we could do -3. I was thinking +2. Sorry, I put negative. And then your y terms would cancel, would eliminate. Be careful to distribute all the way across. You'll be able to solve for x, go back, plug it into whoever you want to solve for y. Done, 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 done. What is another way to solve without substitution or elimination or algebraic processes? You could graph in your graphing calculator. each of the equations in your y equals, if it lets me hit the button, there we go. That was a more complicated function from, I don't even remember what, oh sorry, that was BC. But either way, you could graph both of your equations, but before you graph it, you have to solve for what? Yeah, solve for y in each. Solve for y in each. So you can graph it, you have to play with your window a little bit, and then you can do second trace, find the intersection, right? Find the intersection, and it should match up with the x and y that you found by hand. That's one way to double check your work, or to use your graphing calculator if instructed. One more time, double check your work, or use your graphing calculator when instructed. However, is there another way to use your nifty-difty graphing calculator to check this guy? Yes. Just in case, we're going to actually learn it next chapter, but just in case some of you are like, oh, I've never used matrices before, and the rest of you are like, nah, I'm going to cheat tomorrow. Wednesday. Just so we're all on the same page, you can go ahead and edit if you are allowed to use your graphing calculator. And needing to solve a system, you can check using matrices instead of graphing. A 2 by 3, what does that mean? 2 rows, 3 columns. Why is that good for what I have? How do we get this system into this matrix? What do we do? 1 for the coefficient of x, 1 for the coefficient of y, 10 for the equals. You guys remember this? Then you have 3 for the coefficient of x, negative 2 for the coefficient of y. Is that a 7 that's hiding back there? Yeah. Okay. Now, how do you tell your nifty-difty graphing calculator to solve this for you? So you can double check the same way you could with graphing. Go to the home screen. Then go back to your matrix menu and say, hey, isn't there some math I can do? Oh, yeah, that's fine. And you can scroll all the way down, depending on how updated your calculator is, how new it is. It might be different numbers. Okay, so you're looking for the RREF option. REF is the back substitution one, how you get it in the stair-steppy, and then you have to say Z equals and go back and plug in, go back and plug in. Our REF goes all the way. Oh wait, how do I? Oh. That matrix I just made, his name was A. Hit on A and say dun 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 dun. Oh look. Final answer, you're like, ew, gross, all the multiple choice answers are in fractions. You can do that? Yes. Okay. Anyway, matrices. You can use matrices very similar to graphing in order to double check a system. And why do I keep on saying double check? Why am I graphing? I don't know. Why do I keep saying double check a system?
Because you don't want us to do that in the first thing.
Because if I say in the direction solve using, or if I just say solve, am I saying use your calculator to solve it? No, I'm saying solve it by hand, and I'm giving you space to do so. But I am allowing you to double check with your calculator. Does that make sense? You can double check the answer. However, you will not get full credit on a problem that says solve by hand, even if it's multiple choice. You will not get full credit just by having the right multiple choice answer. Now that made things a little bit more complicated, right? Your work needs to match your answer in order to get full credit. However, are we at least all on the same page how to use our calculators to help us make sure we have the right one? Yes. Now what's a dilemma as soon as you start using your calculator?
Laziness.
Well, I mean more like practical, like more of a practical dilemma. You're taking a test, you're solving it by hand, you're like, ooh, I want to go double check with your calculator. Maybe you notice you're wrong and you go back and try again. Yeah, you just are taking double to triple the time on each problem. Now, if you're feeling really solid about like substitution or elimination, should you necessarily check every single thing in your calculator as you go through the test for the first time? No. My advice would be go through and complete as much of the test as you can, and as you have time, go back and double check. Does that sound good? Yeah. So I wanted to make sure you guys had a strategy. I wanted to make sure we were all on the same page how to use our graphing calculator to double check. That way no one has like an unfair advantage, but also you guys are instructed with, hey, if you use your calculator a lot, it's going to take a lot more time. Kiddos, let's go ahead and just get into our review. But maybe I can give a few more hints on your test. There are going to be systems where you have to solve by substitution by hand. Checking with your calculator if you would like. You can use substitution or elimination. I don't think I'm going to dictate which one. And if I do, we should be able to do both anyway. There could be a question on the test having to do with, hey, use your grapher, get a good window, find the intersection. There might be something I probably won't tell you all that. I'll say, hey, use your graphing calculator, use your grapher, or use the graphs of to solve. Remember, the solutions of a system graphically are the intersections, right? Besides that, in section 7 point, where are we? No, let's keep going. That was elimination. 7.3, we have the stair-step system. There will be at least one of these, the stair-step system. Remember, if it's not in a stair-step, you're supposed to get it in a stair-step using our chains, link by link. Link the first two, get rid of x's. Link the second two, get rid of x's. Link those resulting two, get rid of y's. You have a z. And once it's in the stair-step, easy cheesy, plug in, plug in. And guys, once again, I'd love to let you have your calculators, that way the numbers don't get too messy for you. But you have to show you where to get that full credit, okay? Okay. What happens if we have something, I lost it, something funny where either you only have 2 equations or you have 3 and then the last one just becomes 0, 0, 0, 0? Is it no solution or is there still a way of keeping going? Yeah, it's a true statement. So if you get 0, 0, 0, 0, or if you only have 2 and you really want 3, what's that special way of dealing with that? Let z equal a. Let z equal a would be like your last row, then go back and plug in, go back and plug in. You'll have basically x's, y's, and z's all in terms of a. You probably won't have one of the, like, hey, make a parabola or one of those crazy motion-y problems with heights and times at which the height was. I had those geometry ones where you solve with different angles to set up your system, but I'm not sure if we'll see that tomorrow. Let's keep going to section 7.4. What was going on in there? Decomposition. What were we decomposing? Oh, we were going to partial fractions. Really carefully. Guys, if in a question, guys in the back, if in a question it just says to write the form, are you solving all the way? No, just get the stuff with A's and B's and C's and whatnot. So be careful, because some of you might waste time on a certain question. I'm already warning you, a certain question where you're just supposed to get the A's and B's and you don't have to solve. So don't waste time. Make sure you double check the multiple choice. If there are A's and B's, don't solve all the way. If there are actual numbers, you better go all the way in your partial fractions, okay? There'll probably be a partial fraction, at least 1 or 2 in your multiple choice, and at least 1 solve it all the way in your long answer. Let me see if I can find an example real quick. Nope, that didn't work. Nope, that didn't work. Let's see. I don't see any right away, kiddos, but question. Is there a special type of original problem where you have to do long division first? What? If it's improper, what does it mean for a rational function to be improper? Higher degree is on the top. It's top heavy. However, really quickly, that's what almost everyone thinks, Austin, and that's half right. It's when the degree on the top is greater than or equal to. So either the degrees are tied or the top wins. Do long division first. Maybe something to look at. Otherwise, section 7.5, guys, is basically getting y by itself, if it's a line, or thinking about the circle or the parabola, graphing and then shading. Dotted, solid, shading above or below, depending, and then 7.6 is what we just saw. The constraints. Either I give all the information and you just put it all together, or, I should say, or, there's a word problem you have to translate first and then graph, but you would definitely be able to use your graphing calculator for that. Kiddos, we have about 15 minutes. I'm cool letting you guys just work for the rest. Some of you are already working at school. Hopefully you paid attention to the hints I gave. So I pretty much just walked you through the test. On Wednesday, what are you going to bring to class? Hopefully your notes. Hopefully your brain turned on. Hopefully your homework spiral, ready to go so you don't have to stress about it and try to cram in homework for the rest of the day and turn it in by the end of the day. Hopefully your graphing calculator, which everyone will like to use to check. And think that's it, yeah? Okay, I'm gonna go ahead and pause the video. If anybody is already working on something and you wanna ask me